Bienvenidos, Ushamdi, and welcome CTS231, Section 841 students for the second 8-week term of the fall 2017 semester at Anne Arundel Community College. This is the Networking 4, or the Connecting Networks V6 course from Cisco Networking Academy, and this morning's Packet Tracer tutorial and solution set is going to be on Packet Tracer Activity 3.5.3.4, and we're going to be configuring eBGP, or the Border Gateway Protocol. Now, let's take a look at our topology here, and while we do, BGP is also known as the 3 napkins protocol, like a napkin that you would use while you're eating to wipe your face, because that is how BGP was initially sketched out and created. So the 3 napkins protocol, in fact, if you Google that, there are actually pictures of those 3 napkins and the notes that the individuals who were scribbling on those napkins came up with to come up with BGP. And so here is our setup. You can see we've got different autonomous systems here, right? We've got the AACC network and their autonomous system 65000.0.0.1. We've got the ISP and they're 65000.0.0.3, and they're a transit AS. You see this little annotation here. Now, why is that a transit AS? Well, it's a transit AS because in order for AACC to reach other network, right, they have to transit the ISP, or they have to go through the ISP network. And so that's why it would be referred to as a transit AS. These ASs here, 650.0.0.1 and 0.0.2, are not transit ASs because you can't go through them to reach another AS. So if we had another square over here, right, and let's say this was AS3, right, this would be a transit AS, because you could transit, and I should probably put another router over here, and then it connects into a router in here somewhere, but this would be a transit AS. Again, if we can go through the autonomous system to reach another autonomous system, it would be a transit AS. So let's go ahead and clear our screen here, and let's jump in to this activity. Now, again, this is our first look at BGP. So AACC Incorporated, which is this company right here, hired an ISP to connect to a partner company called Other Company, which is the company over here to the right. So verify that the ISP has provided IP reachability through its network by pinging 1.1.1.9. Now that is the IP address assigned to ISP2's serial 00 interface, which I am going to guess is this one right here. 1.1.1.9. Actually, let me check this. So other company, actually we're going to be checking from the other company. And so let's do that, and we'll check from here. We'll go, oops, sorry. We'll go from AACC. I'm just reading through real quick. There's quite a few instructions here. Let's make sure we get this right. So let's move this up just a skosh. And so here we are on AACC 1. So let's go from user exec to privilege exec, and let's see, can I ping 1.1.1.9? And I can't ping 1.1.1.9 from AACC, but let's see if we can do it here from other. Whoops, from the other network. So let's get our CLI up and get into privilege exec, and can I ping 1.1.1.9? All right, so from other company, we do have connectivity. So from any device inside AACC's network, ping the other company server 172.16.10.2. The ping should fail because we don't have any BGP information. So let's confirm, do I have any BGP information? So let's say show IP route. So as you can see, I've only got my locally connected networks. And the reason that I couldn't ping 1119 from here, right, is I don't have a route, and there's no default route from here either. So if we were to come to this laptop And if I was to try to ping 172.16.10.2, whoops, let's get the ping in there. All right, you can see that we don't have reachability. So configure ACME1 to become an eBGP peer with ISP1. So it gives us our AS number and tells us the internal network that we're going to be advertising via eBGP. Now, what is a little off with this scenario is that we're going to be advertising to this ISP an RFC 1918 subnet. Now, you would not do that because remember, the RFC 1918s, which are the internal private networks, those are not routable on the internet. In fact, this ISP, 99.9999% of the time, is going to have some sort of an access list or some sort of a filter that is going to ensure that if you're trying to advertise what is commonly referred to when we talk about BGP is Network Layer Reachability Information, or NLRI, right? NLRI. And that would be, and NLRI is nothing more than the routes that we're advertising. So the 192.168.0/24. That would be the NLRI that we're advertising because that's our segment back here. However, you would never advertise the internal network to an ISP thinking that this company over here or this autonomous system over here is going to come through if this was AT&T, right? Or if this was Verizon. We wouldn't be advertising the RFC 1918. So keep that in mind. And again, this is Packet Tracer. This is just simply an activity to get us into the mode of thinking about eBGP and how to configure it. Right now, internally in your lab, you can advertise whatever you want, right? But keep in mind, right, they're saying that this is an ISP. And this is typically not something you're going to do because, again, those RFC 1918s, those are not routable on the internet. So let's go ahead, and I'm not sure what just happened there. Let's go ahead, and it says configure ACME1. Whoops. So here's ACME1. Configure ACME1 to become eBGP peer with ISP. So how do we do that? Well, we go into global config, and I say router BGP, and this is where I'm going to put in my autonomous system number. Right, and you can see we can go from 1 to 65,535. Now there is an extended range, right? But it's outside the scope of CCNA, and we'll show that. I'm going to do the same thing here on some real Cisco routers. But we would simply type in our autonomous system number, 65001. And let's see what else they have over here on this side. Configure ACME1 to be the peer. The ISP is using AS number 65003. Use 1111 as the neighbor IP. Okay, so now we need a neighbor statement, right? You can see we've got a limited number of commands here. So who is my neighbor going to be? Well, the neighbor was going to be 1111, and I need to make sure I put in the remote autonomous system number because this is going to dictate whether or not this is an eBGP peering, and that little e stands for external, or whether this is an iBGP peering, which in the little I stands for internal. And we dictate, right, or we classify the peering as iBGP or eBGP based off a very, very simple criteria. If the neighbor's autonomous system number is the same as our autonomous system number, 65001, that would be an iBGP peer. And again, lowercase I there typically. If it's different than our autonomous, and when I say our, I mean I'm on the ACME1 router, right? And ACME1 is here. That is the autonomous system. We're peering with ISP entry 1. They are in a different autonomous system. Therefore, they are considered external BGP peers or eBGP peers, a little lowercase e there, right? So let's go ahead and put in the autonomous system number of ISP 65003. And you can see that the BGP peering comes up immediately, right? So let me grab this and let's give ourselves a little more room here. So the eBGP, excuse me, the eBGP peering comes up immediately. So how would we validate this? Well, let's say show IP BGP. Now I'm going to show you this command here. I'm going to hit enter. We shouldn't see anything yet. In fact, let's say do show IP BGP. We're certainly not going to see anything if we put the wrong syntax in, but we actually are receiving some routing information, right? And show IP BGP by itself is going to show me the BGP routing table, because BGP keeps its own little routing table, right, of BGP specific information that it will then go ahead and put into the global routing table. And this is referred to as the local BGP rib, or sometimes you'll see it as LOC, L-O-C, rib for BGP. And this is where BGP, again, keeps all of its own BGP specific information, and this is where it'll make the determination as to whether or not it's going to put that information into the global rib. So you can see the next hop, right? And let's actually walk through this. So we see the asterisk here, right? That means it's a valid route, and we see the greater than sign, which means it's the best. Now, only the valid and the best ends up in the global rib. So if I was to say do show IP, do show IP route, you can see that we have two of those three BGP routes in the routing table. And it's because they are the valid and they are the best. And you want to see both of those if you expect to see these in your global routing table. So here's the question. This is valid, but it's not the best. Why is it not the best? Now, you've seen this before, and we see this with other dynamic routing protocols when compared to locally connect or directly connected entries. Because remember, the 1110/30, this is a directly connected link here, right? This is a serial link between these two routers. And so the reason that this doesn't show up, and there's actually a command that you can run, it's show BGP IPv4, and I want to say rib failure, if I'm not mistaken. And it'll show you why this is not being entered into the rib. And the reason is because we have a better route for that, and it's right here. It's directly connected, right? You can't beat directly connected when compared to or when compared to pretty much anything, right? So it's directly connected. That is going to be the route that's installed in the routing table because it's directly connected. Doesn't get much better than that. So when BGP says, oh, hey, you know, I've got a BGP route to get there too, the rib is going to say, no, thank you, because I've already got a better, right, a better lower administrative distance to get there. It's directly connected. And that's why we don't see it. We see the next hop, right? So from Acme One's perspective, to get to any of these networks, we're going to have to go to 1111. Now we have the metric, right? And this is referred to as the MED, the multi-exit discriminator. We have a local preference value. And again, these are kind of way outside CCNA scope, but just to touch on these, right? So MED can be used to influence the flow of traffic inbound. Local preference can be used to influence the flow of traffic outbound. Weight is a Cisco proprietary value that Cisco routers use to manipulate. Typically when you have a single router, like we have here, and let's say that we had another connection here to the same ISP, here we could use weight to influence the direction that traffic is going to flow across these two links. And remember, BGP is a path vector routing protocol, path vector, because it uses path attributes. MED is a path attribute. Local preference is a path attribute. And when I say path, I'm talking about the prefixes, the NLRI, the routes, these guys. We can attach attributes, and as you can see, that's why they're listed over here. We can attach attributes to these routes like med, like local preference, like weight, like the AS path. We can attach attributes or manipulate these attributes in order to manipulate the inbound or outbound flow of the BGP traffic. And the text does a very good job. It's kind of interesting, right? So they show us, a single homed connection here, right? And single home meaning we have one connection to the ISP. This is a vintage use case of when you would not use BGP, right? So again, exercise is a great exercise, right? Because it gets us into like, oh, hey, here's how you configure BGP, right? But realistically, if you have a single connection here between you and the ISP, you're not going to be running BGP because BGP is all about manipulating the path attributes that we see here in order to manipulate the flow of traffic, either inbound or outbound. And so with a single connection, how many ways into and out of this autonomous system are there? Yeah, there's only one. So we would simply connect to the service provider and put a default route on Acme 1. And that default route simply points to ISP entry 1, and that's it, we're done, right? Much easier to do that than to get into configuring BGP. Okay, but again, the activity is to introduce us to how to configure eBGP. So, and they do talk about default routes in the text, and that, because we could do BGP here, and ISP entry 1 can originate a default route to me via BGP, and then we'd be all set up and ready to go. So we've got the peering, right? So now what we're going to do, remember, we need to advertise, and let's slide this up a skosh here. We're going to advertise the 192.168, and we do that with a network statement. So 192.168.0.0. Now, you don't say /24 like that, right? What we do is we say mask. We're putting the subnet mask in. And we actually put it in dotted decimal notation. So think of it like this, right? If we were to do OSPF between Acme 1 and ISP entry 1, it would be very, very similar, right? We would say router OSPF 1 instead of router BGP 65001. I would say network 192.168.0.0, and I put a wildcard mask in of a /24, and then the area, right? And so with BGP, it's much the same thing, right? We say router BGP 65001. I put my network statement in, if it's still in there. I put my network statement in, right? Except I use this dotted decimal subnet notation, and then that's it. There is your eBGP peering, right? So our eBGP peering is up. Do show IP BGP summary, right? You can see that the peering is up, right? Messages are being sent. Remember, BGP uses TCP, the Transmission Control Protocol. And the reason that it uses TCP is the designers of BGP took a look at the options. And they said, you know what, we could come up like eIGRP and OSPF. They all have their homebrew, right, or their custom reliability mechanisms built into the protocol. BGP and the designers of BGP said, yeah, we could come up with our own way of doing reliability, but there's this other protocol that's out there called TCP. We're just going to use that. And so that's why they leverage TCP, right? And it uses port 179. And I know the command is not on here, but if I was to say show TCP, I think it's show TCP brief, it will show you the connections on the router, right, from a TCP perspective, and you'll see the BGP setup. And so let's take a look at that real quickly here. Let's see what real Cisco routers look like. So here I am on, and we'll do router 1 here. So if I come over here to router 1 and we go into global config, we go into privilege exec, and then we get into global config. I'm going to say router BGP, and let's do 65001, right? And let's spell BGP 65001. So here I am, and you can see, right, the BGP is very, can become very, very complicated. There's a lot of things we can do here, but we're just interested in this. So if I was to say, not router, sorry, if I was to say neighbor, and the neighbor that we're going to be working with is, we'll do router 2. So 10.1.2.2, and we'll say remote AS is 65002. So I put the neighbor statement in there, and then I'm going to advertise my loopback address. So network 1.1.1.1, and the mask, it's a /32. Now, very important, that subnet mask has to match exactly, right? Has to match exactly. You cannot make a mistake here, or else BGP will simply say, yeah, I don't see a route, a prefix, I don't see NLRI that you would like to advertise that matches what you have in your network statement, right? So they have to be exact. So we type that in and we enter that in. Now, if I was to say do show TCP brief, like I'd mentioned earlier, we don't see anything, right? But that's because there is no TCP connection yet. So let's come over here to router 2, and we'll go into privilege exec and into global config, and I'm going to say router BGP 65002, right? Because that's what we said the remote autonomous system would be. So what kind of a peering is this? What kind of a BGP peering would this be? Exactly. This is going to be an eBGP peering because they're different autonomous system numbers. So I say neighbor, and what is that? 10.1.2.1, and what is the remote autonomous system number? What did we use for the autonomous system number on router 1? We used 65001. And then I'm actually going to also use a network command, and we're going to say 2.2.2.2, and the mask on this is a /32. And there you go. Our BGP peering is up. And it is really, right, from a basic perspective, without getting into a lot of the, getting into the trenches with BGP, it's very straightforward, right? We do the neighbor statement, we do the network statement. There you go. There's our eBGP peering. Now let's say do show IP route, and I could say BGP, right? And there we go. There is the route to the 1111. Can I ping 1111 because I do have network layer reachability information for it? And absolutely, right? So that is an eBGP peering. Now, same thing when we talked about the CHDLC, right? BGP, these routing protocols like BGP and OSPF, these are open standards, right? So theoretically, I could come over here and look, we've still got our ping going here on this Juniper router. So I could come over here to this Juniper router, and I could set BGP up between the Juniper router and the Cisco router. So we'll do the Cisco router first here. So if I was to come over here and say neighbor, and I have no clue, do show IP interface brief and include serial, what addressed 192.168.161. So I would say neighbor 192.168.161.16, and we'll put it in remote AS 65016. Right, we'll just go with the router number. So I'll put that in there, and now let's come over to the Juniper router, right? Because Juniper and Cisco can run BGP between the two routers. So we're going to say set protocol, or actually, what am I going to do here? Set, let's do edit routing options first. So edit routing options, I'm trying to remember what I'm doing here. Oh, where am I at? Okay, I'm in an interface, so let me get up to top. So we're going to say edit routing options. And so this is how you do it on a Juniper router. Obviously not part of the course, right? But let's go ahead, set autonomous system. And here's where we set our autonomous system. We do it under this area called routing options. So 65016. Right? So there is how you do your autonomous system. Now I'm going to say top edit protocols because I have to go to the top of the hierarchy, BGP group, and here's where I can put a group name in. So I'm just going to say eBGP, right? So this will be my group of external BGP peers, and I'm going to set my neighbor to 192.168.161.1. This is router 1. Now, the peering isn't going to come up yet, right? So the peering's not going to come up because, for number one, I haven't set the peer autonomous system, right? This is where we do that neighbor. So Cisco does it all on one line, and I'm going to do it 65001 right here. The other reason, right, is because we don't have, I haven't committed these changes yet, right? And let's go ahead and set type to external, right? So with Juniper, we set the neighbor, we set the peer AS, and we actually say set type external. And now I'm going to commit these changes. And we'll come over here and from a router 1 perspective, we'll go ahead and take a look at things and see what ends up happening over here. And if I'm not mistaken, there it is. All right, fantastic. I was going to say, if I'm not mistaken, I did everything right over there, and we get our peering to come up. So do show IP BGP, right? So here's what we're learning. I'm not getting anything from the other neighbor, but we're going to do show IP BGP summary. Yeah, why not? Take a look at this. So here's my output. Here's my neighbor, right? And this is the router ID. Or I'm sorry, the IP address of the neighbor. Sorry about that. You can see we have our autonomous system listed here. The V is version, right? So BGP version 4. Here are the messages that we've received from those peers. Here's the messages we've sent. Table version is based off the changes that are being made. Input queue and output queue, you always want to see 0 here. Here's how long the peering has been up. And you always want to see a number here, even if it is 0. That implies that the BGP peering is established. If you don't see a number here, it is not established. And again, 0 is a good thing, unless you're expecting prefixes, but 0 is a good thing. It means that the peering is established, it's up. It just means that we haven't received any NLRI. Okay, so now from the Cisco side of the house here, if I was to say do show IP BGP neighbor, right, we're going to get a little more, this gets a little more verbose here, but it gives us some good information. And that piece of information right there, you can see the Cisco side, we never said type external because you don't have to. It knows. It knows it because it's a different autonomous system number, right? So take a look. We see the remote router ID. We see the established information here. Now, BGP, just like OSPF and EIGRP with those hold timers and the dead interval or the dead timers, BGP has the same thing, but BGP is like the tortoise in that old fable, the tortoise and the hare, right, or the turtle and the rabbit. BGP is definitely the turtle, okay? Very, very slow, but very, very steady. Remember, BGP is the routing protocol used on the internet. There are closing in on 700,000 IPv4 routes, right? In addition to all of the IPv6 information, I think there's probably close to 100,000 prefixes out there maybe for IPv6. So again, very, very slow, but super, super stable, right? And this is the internet routing protocol. Now you take a look at neighbor capabilities, right? So it's going to advertise some capabilities of what it is capable of doing. And if we come down a little further, I'm just going to come down far enough so that we can see. And as you can see, there is quite a bit of information here. And so here we go, BGP neighbor. And so here's our Juniper neighbor. And here are the capabilities, the neighbor capabilities that the Juniper router is advertising. But again, you see we're up, right? So you can run BGP between different vendors. No big deal, right? And this is what is done on the internet. So if we transition back to the activity here, it looks like we're halfway through. So we configured that from any device in Acme's network, ping other company server. Again, does it work? So let's ping other company server, and we get destination host. You must also configure their end. Oh, okay. So we've got to configure other company 1. And I'm assuming that that is, there we go. Okay, that's what happened. So other company 1. So let's configure other company 1's connection as well. So let's scoot that up there. So we'll come back here, we'll go into privilege exec, into global config, and we're going to say router BGP 65002. And also, one of the nice things, if you forget the BGP router number, all you have to do is say router BGP and then put a number in. And you can only have one BGP process running on the router. And this is why when I put in that bogus number there, it's going to come up and say, no, 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 no. BGP is already running, and that's the autonomous system number. So if you ever forget your AS, just say router BGP and just throw, like 2222 in there, and it's going to tell you this is actually the autonomous system number, and BGP is already running. So let's get our neighbor statement in here, and let me check here ISP entry 2. Which I'm assuming is this guy here, is going to other company. It's 1119, all right. So we're going to say neighbor 1.1.1.9, and the remote autonomous system is 65003. Right, and that came up awfully quick. And then now let's also advertise, do show IP interface brief. I'm assuming it's going to be that 172. Yep. So we need to advertise that network layer reachability information. So network 172.16.10.0 with a mask, and I'm guessing here, I'll take a look real quick, because again, if that mask is not correct for that network statement, we are dead in the water. It will not be advertised. So where is... I went right by it, I think. There it is. Okay, good. So it is a /24, and it typically is in the packet tracer scenarios, but you have to make sure you get that right, or else it's not going to work. So we're 6 out of 6 right now. That is our configuration. And let's see, verify Acme 1 is properly formed. Yeah, so show IP BGP summary. Absolutely. And there is that state prefix received. Oh, the other thing I wanted to show, I'm sorry. Let me show this real here. Again, show TCP brief, right? So take a look there. And what do you think these numbers are after the period at the end of what appears to be an IP address? 179, 179. Exactly. You've got it. The port number. Right? And what's our state? Our state is established. So just keep this in your back pocket, show TCP brief, because show TCP brief will also show me which router is the server, right? And which router is the client in this BGP configuration. Because remember, the server is listening on port 179. This is a random high port here. Right, on router 1, that is a random high port. But in both cases, router 1 is the client who is connecting to the other router. So router 1 initiated the connection to the other server, because here's that random high port, TCP port being used. So again, good command to know, show TCP brief. All right, so we're back over here. We've got prefixes received. So we're good there. And now let's go ahead and validate. And actually, if I come over here to Acme 1, and we'll say show IP route BGP, you can see that there's that advertisement, because again, this is how the internet works, right? You've got this company here, and they advertise their network out that they want people to be able to reach. The ISP gets it. It'll advertise it with BGP between these ISP routers, and then this guy here is participating with this ISP, and again, we'll just say it's the internet, right? And he's going to get that routing information, and that's why he sees this route. He sees it as a BGP route, the administrative distance of BGP, and specifically eBGP, because iBGP is different. eBGP has an administrative distance of 20. So now let's come back to the laptop. Can we make it over to the other side and back? So the first one times out, but then boom, we're good. Because over here on other company, if I say do show IP route BGP, we know how to get back, right? Remember, it's mutual, what's the word I'm looking for? We need bidirectional information. We need not only the information to get to the network, we need the information to get back from the network to our network. All right. And that is going to wrap up Packet Tracer Activity 3.5.3.4, where we took a look at how to configure basic eBGP. All right, now we go on to the Skills Integration Challenge. Thanks for watching, guys. I will see you Tuesday night.